Anthony Silva here. We're back for another problem for our LeetCode 150 walkthrough on LeetCode. So today we are going to be talking about this problem right here, which, as a Sudoku lover, I am very intrigued by this one. It's a valid Sudoku checker. Alright? So, let's read this real quickly. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the element board, according to the following rules. Alright. So each row must contain the digits 1 through 9 without repetition. Each column must contain the digits 1 through 9 without repetition. And each of the 9 3x3 subboxes of the grid must contain the digits 1 through 9 without repetition. Alright? And then note that a Sudoku board could be valid, but is not necessarily solvable. Alright. And then only the filled cells need to be validated according to the mentioned rules. Alright. Let's take a look at this one here. Alright, so as you can see that every element, each of the 9 digits, each row does not have repeated digits. Each column does not have repeated digits. And then each square, that is these 3x3 grids that you see right here, they don't have repeated digits either. So then the function would have to return true because it is in fact a valid Sudoku. We can't exactly say if it's solvable or not. That's important note, but we can return true here. And then for the second example, let's read this here. So there's a problem with this one. Notice that there are 2 8s here in this first column of the board. So because there's 2 8s in the first column in the same column, it means that this Sudoku is not a valid one to give out to people who want to play this. All right. So now that we've so now that we've examined this problem a little bit, I think we can come up with a pretty simple solution. It's really about trying to make sure you got the necessary information stored and then following the rules word for word. So what we're going to do is create like this empty result array. And then we're going to have to loop through every row in the grid. And yes, it is guaranteed that there are going to be 9 rows, as shown here. We're going to use index I for the rows. We're going to loop through all 9 columns at index J. Now, I know we talked about like nested for loops being a little bit of a problem here in some of these LeetCode solutions that I'm completing. However, it is necessary for this specific problem right here because it's kind of difficult to check to see if you found any like repeated digits without looping through like every single entry in here. But so yeah, that's what for loops are unfortunately the main option here. But don't fret though, since we are only dealing with 9 rows and 9 columns in a 2-dimensional array, that's only going to be like 81 spaces, really. So it won't eat into the time complexity too much with the solution that I'm typing up right here. All right, so we're going to start off with getting the ijth element of our matrix here, or 2D array, whatever you want to call it. Save it to another variable for future use. And then we want to perform a check. And then we want to perform a check to see if we end up with a digit or not. No. If it's a period, we want to just keep going, right? Now, for the 6th step, we're going to add to our resulted array array an element consisting of tuples. Whoops. All right, so we're going to have our row value I, and then our following element. Now we're going to have our element, another tuple with our board element, and the J column. Okay. And then lastly, we want the floor division of the row index by 3. And the floor division of the column index by 3. And then the element itself. And then this tuple represents the 3 by 3 subgrid that the current cell belongs to. So this 7 right here would belong to the upper left corner of the grid. This 9 right here would correspond to the middle element. Okay, I'm confused. Okay, gotcha. So this 9 here would represent the 8th row and the sixth column here. So it would have to be like this mini grid here. And then that's basically what this tuple's going to do. It's going to store which of those mini 3 by 3 grids are in the that DA element stored. Okay. So now we want to compare our result array to a set. And we actually want to compare their lengths. All right. And then why would we want to use this comparison operator as our return statement? Well, we want to check to see if we have the same tuples in our resultant array, which could happen. Could happen. And recall that if we want to append to a set, an element to a set that already exists in the set, that element will simply not be added. It will just added. So if we end up with one of those situations where one is not added to the set, then the length of our set would be would be less than the length of our resultant array itself. So that's why our returns value works here. I mean, pretty good, honestly. I think this is probably the best way to go about this, even though it's an O of n squared solution. But again, uh, going through every single, going through all 81 values of our matrix is essential to making sure that the problem is solved correctly. Since we are trying to add an extra set here, I will say that this is probably going to be an O of n space complexity. It might not exactly be like n elements. No, mm, the m n elements. There's the elements, but this is just going to be the worst case scenario that we want to draw here. Like our input, like matrix, could potentially be like a completely filled, and then our result, and then it would end up being valid no matter what. So just keep that in mind that does contribute to a lot of space here, but it honestly could be a whole lot worse. Like we could have used like multiple like arrays and that sort of thing, and I don't think that's something we want to uh try try to do a quick fix on. It's gonna make things a lot more difficult. But anyways, we start with our resultant array, which gonna start as empty. All right. We'll look through all 9 rows. We'll go through all 9 columns. We get our element from I and J. We want to perform a check on the number if it is a number, so it is not a period. And then we have our set of tuples. Comma separated, Anthony. Comma separated. All right. This is where our ith row is going to be stored. Then our j column. And then we get our floor division of our elements. So to get our mini 3x3 grid that our element is stored. All right. And then we return result equals, check the length of result. We can't really compare an array to a set that easily. But we can compare 2 numbers, and we can get numbers by getting the lengths of our data structures. Should work just fine though. Let's just make sure. Okay, perfect. Let's submit this. Okay. So yeah, this is it's pretty sufficient right here. I mean, I need, like I said, these might not be the best time and space complexities, but if you know for a fact that this is basically the best you could do, then go ahead and tell the interviewer that, but explain why you can't exactly simplify this much further. That's what if this problem did come up in an interview at a later point in time, right? But anyways, that's it. That is it for today. Thank you so much for watching. Be sure to subscribe to my channel to stay tuned for the next problem that I'm going to do, next time I'm actually going to be doing the final problem in the LeetCode 150 arrays and hashing set, and then we'll be moving on to a different set of problems. So pretty exciting stuff, so please sure to stay tuned for that. And don't forget to check the comment section below this video for my solutions in C++ and Java too. Okay? Again, thanks so much for watching, guys. So long.